Good morning, everyone. My name is Keira Proctor, and I'm the Managing Director of the A. Proctor Group Limited. And welcome once again to our weekly webinar. This is number 8, and if you want to go back and catch up, all the previous webinars are available on our website at www.proctorgroup.com and also on our YouTube channel. You can register for CPD certification too, and feel free to share them with anyone you think might be interested. So today we're going to talk about the fire performance of construction membranes and how this can be accounted for and integrated into a fire-focused design process. Since the tragic events at Grenfell in 2017, a good proportion of the construction industry has quite rightly been focused on how we can improve the fire resistance of our buildings and how we can prevent situations where the as-built fire performance tragically fails to be realised in practice. The 2018 report by Dame Judith Hackett, Building a Safer Future, was highly critical in its assessment of both the industry and the regulations. Its references to negotiating down the standards given in the approved documents and to the opaque and confusing nature of that same guidance will be all too familiar to everyone in the industry. Following its publication, the report received criticism for not suggesting an outright ban on combustible materials in high-rise residential. But this is perhaps unfair given the focus of the document. What it highlights as being of primary importance is clarity of information and guidance, and the implementation of clear and transparent procedures to ensure the information is both correct and is distributed to where it is needed with the design team. So today we're going to base this presentation around 4 main aims. Gaining an understanding of the fire design process across disciplines. Familiarity with the fundamental regulations and guidance, what product information and testing is critical to ensure compliance, and finally, how to ensure as-built performance matches the design criteria. We'll consider how this can be achieved from our perspective as manufacturers and from that of specifiers and installers, and look at how we can ensure we use the correct tools to transfer the correct information throughout the design and build process. As manufacturers of membranes which can be used in fire safety critical applications, we have a responsibility to ensure the systems and materials we supply are fit for purpose, but we must also provide specifiers with sufficient information to integrate those systems into the wider design without causing problems. So let's begin by considering some of the fire tests that are used and how they relate to the specifics of particular designs. BS 476. Historically, BS 476 was the most commonly used form of fire testing in the UK, and it's comprised of various different sections or parts. The commonly referenced of these parts were parts 4 and 6, 7 and 11, which variously deal with the combustibility and fire spread characteristics of materials. BS 476 tests, however, are bench scale tests, so they're conducted on very small samples and are tightly focused on a particular aspect of performance in isolation. For example, BS 476 Part 4 uses a small furnace heated to 750 degrees, into which is placed a 40 by 40 by 50 mm sample of the material under test. For many years, this was the only test used to determine combustibility of material in the UK, although, as you may have noticed, the test setup does not particularly resemble a realistic subassembly of a building. The situation is similar with the BS 476 Part 7 test, which uses a combination of radiant heat and pilot flames to measure the rate at which flame propagates across a surface. As with the other parts of BS 476, this is a perfectly valid and repeatable test method, but not one which has any particular resemblance to the application of a material in a building context. It's also possible, as was the case with some types of foam cored aluminium panels, that a product or material may achieve a good result in the surface spread of flame testing whilst remaining essentially combustible. The building regulations which reference BS 476 did not always account for these factors, which was a contributing factor leading to the use of combustible ACM cladding on Grenfell Tower and other projects, most of which are now undergoing extensive remediation works. The EN ISO 13501 Euroclass fire classification system is a newer and more extensive test regime introduced to harmonise fire testing across the EU. The classification system relies on data from several test methods, some of which are similar to those by BS 476, such as EN ISO 1182, which tests combustibility, and EN ISO 1716, which determines the calorific value of energy release associated with combustion. This energy release is particularly important consideration for membranes, which, while often combustible, will have virtually no effect on overall fire development due to their lack of calorific value. The crucial step forward from the older test methodologies is both in the EN 13823 single burning item test and in the simplified classification system, which expresses many performance criteria in a single, easily comparable value. It's also worth noting at this point that as this is a Europe-wide test, it can be found quoted in a variety of ways. In the UK, it may be referred to as BS EN ISO 13501, while Germany, for example, may use a DIN EN ISO prefix to reference the exact same test. The single burning item test is an intermediate scale test where a standardised test assembly is exposed to direct ignition from a flame source. The amount of heat and smoke produced during the test is then measured and used to determine the following characteristics: total heat release, THR, and total smoke production, TSP, simply the total amounts of heat energy and smoke produced by combustion during the 20-minute test period. Lateral flame spread, the extent of flame movement relative to the edges of the test specimen. Fire growth rate index, the rate of increase of heat production during the test. Smoke growth rate, the rate of increase of smoke production during the test. Flaming droplets particles, a visual assessment of any droplets which continue to flame for longer than 10 seconds after reaching the ground. These are all brought together into the Euroclass rating, which works like this. Class A1 materials are fully non-reactive when exposed to fire, such as cement, minerals and glass, whilst those in Class A2 have an extremely limited reaction in terms of smoke and droplet production. Class B products are combustible but with a very limited contribution to the overall fire development, with C to E products making increasingly large contributions to the fire development. Alongside this, the classification adds the S and the D suffixes, denoting smoke emission and droplet productions. S1 means smoke emission is weak or absent, through to S3, meaning high-intensity smoke production. Likewise, D0 is no droplets, while D2 means high levels of dripping. This simple and universal system makes comparisons of fire characteristics simple in regulatory terms, but it's not without problems as the classes can accommodate a broad range of performances. This test here, conducted by the University of Edinburgh, is a comparative test based on the single burning item test, and shows our fire shield membrane next to a competing material. Both these materials have an identical Class B S1 D0 rating on paper, so could be considered equivalent. In practice, though, the difference in performance is obvious. How this disparity can be tested, quantified and accounted for in regulations is something we are currently discussing with the BBA amongst others. The fire shield is a BBA certified vapour permeable membrane for use in timber frame wall and facade applications where fire performance is of paramount importance. The most recent test method used in the UK is the BS 8414 test, revised just this year. This is the largest scale test commonly used and aims to give an accurate representation of the performance of a fully integrated wall assembly. In essence, this test is a supersized single burning item test, with the 1.5 metres high test panel increased to 8 metres and the peak heat release from the test fire taken from 30 kilowatts to 4.5 megawatts. In this test, products are tested integrated into complete constructions, with additional components making up the entire wall assembly present. The fire source, called a crib, is inset at the bottom of the test structure to simulate a fire breaking out of a window and spreading up a facade. After ignition, the system is observed and the thermocouples are used to measure temperature at various points on the sample. The test is run for a period of 30 minutes unless the flames extend above the test sample or there is a risk to personnel or equipment. In either of these cases, the test is terminated and the system cannot be classified. After the test is completed, the system is assessed according to the following criteria. External fire spread. Based on external thermocouple temperatures, which should not exceed their initial reading by more than 600 degrees for 30 seconds, within a period of 15 minutes from the start time. Internal fire spread, which uses the same criteria as external, but based on the temperatures of thermocouples located within the structure. Mechanical performance. A written assessment of the damage to the test sample detailing any collapse, delamination of components, and general damage. In this image, you can see the post-test condition of our wrap-tight membrane, which in this case was behind a layer of incombustible mineral fibre and has suffered minimal damage. The wrap-tight has a BS1 D0 classification, which means that its contribution to the development of the fire is negligible, both in terms of smoke production and overall energy release. But in this case, the overall construction has substantially protected the membrane from ignition, highlighting the importance of integrated system testing. Alongside these various tests, third-party product certification and accreditation can also be vital in determining the suitability of a product or system for a given application. Documentation like BBA certification can include details on fire ratings and any restrictions that may apply, such as ratings only being applicable to specific substrates, which may be necessary to consider. The main thing to consider, whether the information comes from test reports or from certification or from manufacturers themselves, is to ensure that the information is applicable to the situation under consideration and is the best available for that product. When considering the fire performance of structures, specifiers have to balance combustibility against a range of performance factors. While it's easy to simply say we'll make the entire structure incombustible, this may have impacts on the hygrothermal performance of the building or on its air leakage. Some weatherproofing systems, whilst incombustible, do not allow sufficient moisture to transfer to comply with the recommendation of BS 5250, the Code of Practice for Condensation Control. So in upgrading fire performance, we may create problems in other areas. The challenge, therefore, is to balance the fire-related aspect of the design with other factors, like ensuring acceptable energy performance and healthy indoor environments, without compromising on the critical safety considerations. So how can this be done? The key to achieving the delicate compromise is good information based on the criteria we discussed earlier. Ensuring primarily that materials used in the design are incombustible where appropriate and practical, but that where combustible products must be used, any fire risk is minimised and clearly understood in the overall context. Without good test data for products, this is very difficult, and even if the data is available, successfully integrating designs will require expertise from all parts of the design process. It's no longer sufficient to simply specify a material as part of, for example, a facade build-up and trust that detailing around features like windows, fire breaks and element junctions will be adequately resolved. Input from all parties, from product manufacturers to site operatives, is the key to ensuring a robust design is developed that not only meets on-paper requirements of the building regulations, but actually provides meaningful performance. To return to Dame Hackett's quote about negotiating down standards, it's important to comply not just with the letter of the regulation, but also with the spirit, something not always taken sufficiently seriously in the past. A good understanding of the materials and constructions must sit alongside a good understanding of the building regulations themselves. There are three main approaches that can be taken. One based on the building regulations and approved documents, a risk management approach using the principles given in BS 9999 and BS 9991, and a fully engineered approach from first principles. The latter two are considerably more project-specific methods, so today we'll mainly consider a regulation-based approach, which is by far the most widely acceptable and the closest thing available to a standardised method. In the case of fire, that means Part B in England and Wales, Section 2 in Scotland, Part E in Northern Ireland, and Technical Guidance Document B in the Republic of Ireland. As always, there are some differences which we'll highlight, but we'll try to keep as broadly applicable as we can. The Building Research Establishment's BR 135 guidance document is also important when considering fire design, as is Regulation 7 covering materials and workmanship. Regulation 7 and Approved Document B, ADB, were historically somewhat ambiguous, and therefore the reading and interpretation of them could result in flawed or even potentially dangerous outcomes in design and specification. This is of particular importance in high-rise applications. In late 2018, they were both updated to improve, strengthen and clarify the message, language, terminology and examples in order to simplify the information and remove any ambiguity regarding what is required. One of the main changes was the shift in classification of materials within ADB and the removal of references to BS 476-6 and 7, which classified products for spread of flame. As we saw earlier, the issue with this classification was that it only took into account the reaction of the surface of the material being tested and did not consider the combustibility of the whole product. Document B also includes the concept of relevant buildings, being more or less any building intended for residential use which is over 18 metres in height, and these require most materials to achieve at least Class A2. In Scotland, similar changes took place in 2005, with the building regulations shifting away from BS 476 classifications to requiring cladding materials to be either non-combustible or tested as part of a complete system. This applied to new build and refurbishment works. As we discussed previously, however, commonly used types of membranes such as vapor permeable or breather membranes are not able to meet the necessary criteria for combustibility without severely compromising their ability to perform their essential function, as this is recognised in the building regulations, with ADB stating, membranes used as part of the external wall construction should achieve a minimum classification of European Class B-S3D0. A similar exemption is provided in Scottish Technical Standard 2, but the cut-off point for construction to be considered as high-rise is lower in Scotland, at 11 metres as opposed to 18 metres. The BR135 guidance document uses the following model to illustrate the development of a fire. We covered this in our recent modular and facade webinar, but it's worth repeating as it illustrates well the effect and purpose of the reduced combustibility requirements. A rapid fire spread occurs when an initial fire develops and flashes over, and is then spread to all areas simultaneously by the outer cladding layers, in turn starting fires across all areas of the building. Where fire spread is restricted, the initial fire develops and flashes over, but can only ignite a single secondary fire directly adjacent. The fire will only develop further if this secondary fire also develops. This is a much slower process and allows far more time to contain each area of fire and to evacuate occupants. In this model, how any external membranes react to fire is important. If the membrane is mechanically fixed and taped, there is the potential for fire to spread on both surfaces of the material, as oxygen can feed into the fire from either side. With a fully adhered membrane like Raptite, only the outer surface can contribute to the development of the fire, as there are no gaps between the membrane and the substrate. This inhibits the supply of oxygen to the fire and slows down the spread of fire across the membrane. This again highlights why a more joined-up approach to design brings benefits when the overall performance of the structure is considered. The Structural Timber Association also has design codes and guidance for fire protection in timber frame, and of particular note in this guidance is the minimum separating distances between properties and the effect a fire-resistant construction can have in reducing these distances. This guidance is based on determining the heat flux from a burning structure and how this is transmitted to adjoining plots, and is based in part on large-scale testing conducted at the BRE. The STA guidance places timber frame structures into 3 categories, A, B and C, with differing guidance for each type. Type A comprised a standard timber frame and sheathing, with no particular fire-resisting measures applied. Type B is an enhanced frame, built and tested to meet the STA's FR build standard, with sheathing materials of limited combustibility. Type C is a fire-robust panel frame, which further reduces the combustibility of both the sheathing and internal linings. Type B and C also introduce FR build or non-combustibility requirements for internal walls and floors to ensure the overall structure is fully protected. It's also important to remember that this FR build spec sits separately from the testing we discussed earlier, and it's something more applicable to timber frame manufacturers and suppliers than to specifiers, as structural systems must be tested within accordance of the STA technical paper procedures as complete assemblies. That said, it's still worth being aware of this, as the availability of the STA FR build systems may influence specifiers' choices of suppliers if fire is a critical consideration. Timber frame or panel fabricators should contact the STA directly for further advice on how to comply with this, but our fire shield vapour permeable membrane is fully tested and suitable for inclusion in such systems. Once the frame specification is confirmed, this table can then be used to cross-reference the classification of the building against the building size. This gives a minimum separating distance based on the emission of heat energy required to cause ignition of adjacent structures. Another good example of the benefits of this approach is the detailing of junctions and openings, where without careful consideration of the specification and the involvement of multiple parties in the design, problems can arise. Here we can see a window frame detail with a thermal break specified at the perimeter. The purpose of this thermal break is to limit the effects of cold bridging. This doesn't just mean reducing the overall heat loss, but also serves to increase the surface temperature and minimise the risk of condensation in this area. In theory, this is pretty straightforward. Add some insulation, vapour barrier, and problem solved. But when we introduce a fire requirement, we then have to ensure this can be achieved without compromising either the combustibility or hygrothermal performance. On top of that, we have to ensure that this can be delivered in a way that is easy to install effectively. In this case, our Spacetherm Slentex A2 insulation was used at the perimeters to maximise the insulation performance without compromising on the reaction to fire. The Class A2S1D0 aerogel insulation can be supplied laminated to a variety of facing materials and can also be custom cut to meet project requirements, leading to a faster and more accurate installation procedure. The detail can then be completed using the ProCheck A2 or ProCheck FR200 vapour control layer internally and Fire Shield externally. This gives a fully protected and highly effective thermal break, minimising heat loss and condensation risk without increasing the fire risks. Another project where the Spacetherm Slentex A2 found use was the refurbishment of the 27-storey Balfron Tower in Tower Hamlets, London. This iconic 1960s building, designed by Erno Goldfinger, houses 146 apartments and was recently upgraded to bring it up to modern standards in terms of fire, acoustic and thermal performance. Development architects Egray West identified a particular issue around the concrete stairwell walls, particularly space-critical areas and vulnerable to cold bridging. There were also similar issues at window and door junctions to address. In the stairwell areas, the original specification called for 145 mm of insulation to maintain condensation-free surface temperature of 16 degrees. However, the use of the Spacetherm system reduced this to under 60 mm. Both of these examples illustrate the benefits that involving product manufacturers in the design process can bring, and this can be extended to facade systems, both in new build and recladding applications. In this project, student accommodation in Newcastle, the BS1D0 rated wrap-type membrane was able to deliver low air leakage rates. This was done simply and quickly by minimising the sealing of surfaces that an internal air barrier would require. It was also able to deliver the reaction to fire characteristics required to be used on a residential structure over 18 metres in height. These low air leakage rates can be used to offset performance differences associated with non-combustible insulation materials, giving designers increased flexibility in the design choices they make. This project in London used this approach to replace originally specified PIR insulation with mineral fibre, reducing fire risks while minimising the impact of thermal performance. Increasingly common are recladding projects such as this high-rise residential block in London, where Fire Shield has been used to enhance the performance of the upgraded facade. In all these cases, by being involved in the design process, we were able, as manufacturers, to assist specifiers in meeting their objectives by providing calculations and test data to support the use of materials that may not have been initially considered if looked at in isolation. This integrated design approach can be carried forward to site also, where, as manufacturers, we have to utilise our expertise not just in regards to specification, but also to the practicalities of installation. This knowledge can be applied firstly to ensure specifications as drawn are physically possible on site, and then to ensure the correct processes are followed to bring the project to fruition. By applying this knowledge and experience to site installation, we can help ensure that installers of fire-rated systems are aware of the critical impact their processes have on the overall performance of the system. This doesn't just mean that systems have to be fitted correctly, but means that switches in specification must be minimalised if they take place at all. Regular viewers of our webinars will remember we discussed designing for manufacture and assembly a couple of weeks ago, and these principles are a good basis for considering fire performance also. A well-designed system will facilitate straightforward installation, and this design will form part of a process where material specifications are agreed and fixed, meaning products can be sourced in sufficient time so that specification changes will be unnecessary. This optimisation of deliveries and installation processes will be particularly important in light of any quarantine restrictions post-lockdown, as work practices on site will have to be carefully planned and controlled. In this detail, we can see a common situation in a facade application, a floor junction. In these areas, there are a number of requirements to account for in any installation, and ensuring this is done correctly as these requirements intersect in various ways. The joints here must be capable of accommodating structural expansion and contraction. They must not introduce a cold bridge. They must adequately resist air leakage, and finally must limit the potential for fire to spread between floors up the facade of the building. Each of these requirements require careful detailing at the design stage, and even more careful installation to achieve on site, but with a good choice of materials it is possible to mitigate these risks by simplifying the process. The wrap-type membrane used over the sheathing and slab edges is key to this simplification. Used of foam compression strips at expansion joints, the flexibility and self-adhesion of the membrane allows structural movements to be accommodated without risking overstressing the airtight layer. Being external, this airtight layer reduces the need for proprietary tapes and gaskets, which may be difficult to source and may also introduce complications as regards to fire performance, if suitably fire-rated components cannot be easily sourced. Coupled with the faster self-adhesive installation process, this greatly simplifies and speeds up on-site procedures. With the airtightness aspect dealt with, the outer layers of the construction can then be applied, with a permeable and incombustible insulation layer preventing fire spread both itself and by limiting the potential for the membrane to be exposed to flame. This, combined with the fully adhering backing of the wrap-tight, reduces the potential for both heat and oxygen to reach the membrane from either side, removing the two key aspects of the fire triangle required for combustion. Fire breaks and cavity barriers can then be added without too much concern as to how they affect air leakage. What this build-up achieves is breaking the complex interaction of requirements in this area into a straightforward series of linear processes. As manufacturers, we also undertake to support site operatives through training both on and off-site to further assist in streamlining these processes and increasing skill sets. We're obviously not doing as much of this on-site training lately, but we're very much looking forward to getting back into our toolbox talks on-site and working with installers across the industry. So please feel free to get in touch if that's something that you're interested in. We firmly believe as a business that CPD is not just relevant to specifiers, but something that can be applied across the whole design and build chain. Increasing and transferring knowledge of both materials and processes is the key to achieving a good balanced design strategy across all types of buildings and is particularly important where safety is of critical consideration. So I hope that today we've illustrated the type of information and testing that designers should look for, how that information can be used to inform their design choices, and how we as materials suppliers can be a responsible and collaborative partner in those choices for both specifiers and contractors. We'll now move on to our Q&A session. Good morning, everyone. First of all, thank you all very much for attending. I hope everyone is well and taking care. It's great to see so many people watching the live feed, even some comments from some old faces. So a couple that used to work for us. Lovely to see you, and I hope you're all doing absolutely great. As you know, we will stay on and we will answer, well, if you've been to one of our webinars before, we will stay on and try our best to answer all your questions. So please either ask them on the YouTube feed, email them to us at webinar@proctorgroup.com, or you can also direct message us on Twitter. Fire safety is quite an expansive and evolving area of legislation at the moment. Even a number of changes in just this week in terms of the latest revisions to approved document B on Wednesday of this week, and on Tuesday, comments closed for the new government technical consultation regarding the use of and the ban of combustible materials. So it is quite it's quite an interesting and expansive topic. So as membrane manufacturers and providers, we will try our best to answer all your questions. And of course, any in relation to specification of our products, installation, general detailing, and the wider picture. But there may be some questions with regards to fire safety which are out with our remit. So that's absolutely fine, and we will just say that. The last thing we'd want to do is give incorrect information on such a critical topic. So we will let you know. Just a couple of semantics before I introduce people. You can get personalised CPD certification. It's posted in the link below, just under the YouTube video, which is live. We love getting your feedback. So afterwards, you'll receive an email which gives you a replay of the webinar, which you can feel free to circulate to colleagues, peers, friends, whoever may enjoy it, along with a short survey. So if you can feedback, we would really appreciate it. Our next webinar is going to be in 2 weeks, so we've moved as from June to bi-weekly. A couple of reasons. Some of the feedback we were getting in the surveys after the webinar is that they're great, but they're quite a commitment every single week. They're also a big commitment for us, so that fitted in quite well because we want to keep the content as interesting as we can. So it will be in 2 weeks on Friday the 12th of June. So if you can make it, please diary it. And the topic will be advanced membranes for offsite housing. So that's something we know an awful lot about, and we've been in it for many, many years. So again, something educational and interesting, hopefully, for you guys. So this week, some familiar faces that you may have seen. Callum Anderson is in our technical team. He's kind of known internally as the WUFI calculation man, background in architectural technician, and based in Crieff, near me, so he's enjoying the nice weather hopefully outside today. James Brackenreed Johnson is based in Eastbourne, so he's our London specification manager, a lot of experience in high-rise and facades, and this topic in particular. So again, someone that can help you either today or after the webinar. Can get in touch with any of the team. And Mark Lambourne, who has been in the construction sector for 34 years, I think, is a historic Proctor employee that we managed to coax back to come work for us again in the last year. So it's great to have him back. And he's based in Ripley in Derby. So we're all working from our home offices or kitchens, as I am. And yeah, so hope you enjoy the Q&A. We won't be offended if you leave early. Sort of in British way, you might not want to leave, because if you have other things to do, please feel free, or you can stay as long as you like. Okay, great. So as I said, the Proctor Group has said on the YouTube feed, we have some via email and some coming in now on the chat. So please post more here if you have any. Please don't email questions to reception@Proctor Group. They won't be picked up. So if you have emailed there, please re-email them to webinar@proctorgroup.com. Okay, great. So who to pick on first? Callum, you're looking very innocent there, so we'll start with you. So Josh has asked, you mentioned that approved document B is not the only route to compliance. Could you elaborate on this, please?
Yes, so there's also things like the Building Bulletin 100 or the British Standards 9999 or 9991. These are site-specific things that a fire engineer can do a desktop study on. So it means that they can offset some factors against others. For example, they can make the egress routes different to allow for less combustible materials or things like that. It's not a service that we can provide, as I say, it does have to be done by a qualified fire engineer, but our products can still be used as the same principles to apply.
Okay, that's great. Thank you, Callum. Callum, if I can ask you one from the YouTube feed as well, please. So we've got here, there's quite a few coming through, just bear with me one second. Thomas has asked, Callum, do Proctor Group offer any non-combustible warm roof balcony terrace waterproofing membranes?
I'm afraid not. We don't offer any membranes that are exclusively for waterproofing at all. So most of our membranes are just water resistant, so for secondary water protection.
Okay, that's great. Thank you. Mark, morning.
Morning.
Liam has asked, we're currently in the early design stage of having luxury apartment rental scheme in Manchester, and our preference is to specify an internal AVCL. Which membrane is best suited, and how do we obtain samples?
Morning, everyone. Well, samples are available. You can go on our website and order samples that way. Drop us an email. Is another way of doing that. So they're freely available, as are all the brochures if you want those in hard copy. Some of us are a bit old-fashioned and like things in hard copy, where others are quite happy just to download off PDF. In terms of an internal AVCL membrane, highest performing product that we have in the range is ProCheck A2. So that's a fire classification of A2 S1D0. So that's a really high performing VCL and internal air barrier membrane, if that's the way you want to sort of achieve the air tightness by using internal membrane. So the product has two faces to it. The face that would face the fire risk, as it were, is the foil face. So that would be installed, if you're installing the membrane internally, that's the face that the guys would see when they're installing it. And having a foil face, it provides a really high resistance to the passaging water vapor. So SD value of 1,500 meters. And as with all VCLs, really, I guess it's good practice that you should incorporate a service void. So that will prevent any damage for follow-on trades, etc. And by having that service void, a minimum 19 millimeters of depth, you can then account for the low emissivity surface of that membrane. So that in our U-value calculations and condensation risk analysis, we can account for that enhanced thermal resistance. So that really is the membrane that's best suited for the external wall of the facade, of the build, etc. But internally, if you're renting these properties out, you may want to consider a different solution for the internal walls, and walls which sort of go on to common areas, etc. So there'll be a differential perhaps in some of the units where you've got someone that's actually occupying that unit, but the adjacent unit may be left unheated, and no one will be in that unit for quite some time. So there's a differential there in terms of moisture management, etc. So you may want to employ a variable VCL at that point. So we have a product called ProCheck Adapt, variable resistance, that will really benefit that type of construction. So if you get in touch, by all means, we can discuss that further and provide more detail and specification, etc.
Okay, thanks, Mark. Morning, James. If I can come to you for one YouTube feed, and then I got a few via email as well. So Daniello has asked, fire cavity barrier. Let me start that again, sorry. Fire cavity barrier require VCL and horizontal cavity tray, he thinks. Can we use the ProCheck as the vapor control layer?
You're muted, James.
Oh, James, sorry.
Sorry, traditionally wise, you're looking at your VCL being on the internal side of your build-up and your breather membrane being on the outside. There is the instance where you can utilize the VCL to, if you've got a concrete frame, then you can utilize that VCL to wrap around the concrete frame. So in this purpose, especially when you've got your cavity barriers, your fire cavity barriers, then yes, you can use the A2 ProCheck because it conforms to regulation in regards to a facade membrane. So if you're utilizing that VCL in that facade as opposed to the traditional way of having it internally, then it still conforms as it's a class A2 S1D0 membrane.
Okay, brilliant.
But obviously, please, as alluded to all the time within the Proctor Group, please get in touch. And we will obviously put that detail together for you based on the drawings that you've already got. We can adapt those drawings to make sure that you've got the VCL and the breather membrane in the right lines, in the right places.
Okay, that's great. Thank you, James. There was obviously quite a conversation, well, a part in our webinar about the different classes, and Ben has asked, why is Fire Shield a Class B? Is that one you can answer?
Yes, I mean, from a fire shield point of view, if you take it back more to a membranes point of view, it's been a copy and paste specification for years in regards to membranes. So whether it's your VCL, whether it's your breather membrane, the product has been negated in regards to testing and basically how much of a product and what it's involved in the facade system. Because of the unfortunate events of Grenfell, these facade systems were taken apart, and each individual element was then looked at in closer inspection. As you've seen from the changes in ADB in recent years, membranes have now become, you need to achieve a certain class rating with that membrane. So they're becoming more sensitive within that area. So in regards to Fire Shield and its rating, the rating is Class B S1D0, but as you saw from the video, its ability to stop the spread of flame is very efficient and effective. However, there's still a reaction from the surface to that flame. So as opposed to recoiling from the fire, we inchmess or foam. And what, as Keira stated in the webinar, we're working with BBA to enhance that classification. So what we're looking for is to show them, as we've shown you, that the product behaves in a completely different way to an equally or similarly approved product. I know we don't like that, but equally or similarly approved product. But so we're working on it to sort of push it forwards so that it's no longer classified with all the other mainstream membranes in that class, so it can pick above and beyond.
Okay, that's great. Thank you, James. Cam, if I can come to you, one from Ian Lander, an old friend that used to work for us. Let's have a look. So he's saying he now works for a supplier of facade systems, so he doesn't tend to get involved with membranes. However, would the installation of the membranes mentioned usually fall within the remit of the cladding installers?
It depends. It can be installed by, it is installed by a variety of contractors. Some of those are involved in cladding, others are involved in the entire through-wall build-up. Typically, it would be done before the insulation goes on, so it's before the cladding really has much to do with it at all. But it can be done by the cladding contractors. Okay.
That's great. Thank you, Callum. And Callum, Paul has asked, another via email, what is the advantage of a self-adhered membrane in regards to fire?
Okay, so I believe that was mentioned in the webinar. With a typical mechanically fixed membrane, you have two sides where oxygen can be provided to that membrane to fuel the fire. Whereas with a self-adhered membrane, it's only one side, as the other side's fully against the wall, and there's no airflow behind that. With a membrane such as Wrap-Tite, you've also got the advantage of not having any unmitigated air loss, which can be a path for fire to flow through.
Okay, that's great. Thank you, Callum. I've just seen another question come through from Philip with regards to cost with Fire Shield membrane. We do try and keep these mainly technical. I do know that there is it is a more expensive membrane than a traditional walling membrane, for example. But if you could please email us, then we'll get back to you and have a look at that. I don't know off the top of my head, and these guys are all in technical specification rather than actually sales individuals, so they wouldn't have the prices in their head. So if you could email us, please, we'll come back to you on that. I'm sorry, we don't have an answer straight away. Mark, if I can come back to you, please, on a question from Ray. Can Fire Shield be installed over the sheathing board and behind non-combustible mineral wool insulation?
Well, Fire Shield, as James said earlier, as a Class B S1D0, but as we saw in the video there, it performs differently. So the surface of the membrane actually foams up. It's like an intermescent material and actively prevents the passage of fire across the membrane and protects the surface behind. So it's installed to a substrate as would a traditional breather membrane. So it's mechanically fixed and installed in very much the same way. So 150 mil laps vertical, 100 horizontal, and fixings generally about 450 maximum centers. Now, what we need from that membrane is obviously for that coating to actually foam up and actively reduce fire spread. So it's not really suited for use behind the insulation. We want that membrane to be within the external face of the cavity, as it were, so it can react in the event of fire. If you want a membrane that's being used behind, say, Rockwood Duo slab, for example, on a typical high-rise facade, then really the product is wrap type. And again, class B S1D0, and that would be the best solution, as we saw from the webinar. It's self-adhered back to the substrate, eliminates the need for fixings, can take out a lot of the EPDM, so take out all of that across the concrete columns, floor zones, etc. And really, from Callum's department, he can determine through the hydrothermal assessment whether we can eliminate the internal VCL. So from the main contractor's point of view, by using wrap type and putting the air tightness line externally, he's got one contractor to think about in terms of that through wall build-up, rather than having 2 or 3 different contractors. Sure. And going back to Ian's question, I guess, in our experience, it's actually the facade contractor that will install these type of membranes, and perhaps we ought to be having a conversation with him as going forward with a complete system approach.
Yeah. Thank you, Mark. Very good. James, I haven't been to you for a while. I'm trying to keep track of the questions and who I'm going to hear. So Dave has asked, due to the requirement for non-combustible materials for balconies, can the slime text be used to insulate them? Good question. Yeah.
The product again is an A2 S1D0, so it's not necessarily stated as being non-combustible, but it is permitted to be utilised on those balconies. We haven't actually tested it as yet. It's something that we're working on. It would perform thermally, but obviously we're looking into the cooling effect from rainwater in the inverted scenario on those balconies. That's the way it's going to be installed. That needs to be taken into consideration. Indeed, the compressive strength of the product being at 30 kilopascals at 10%, obviously it's not ideal for, say, having pucks and slabs on top of it. So that would have to be designed into the situation as well. Pros for it obviously is a very thin product. It's got the A2S1D0 classification. The product is hydrophobic, so it actively repels water. So there will be no retention of water or moisture within the product, so it won't affect the lambda or the U value that you're getting from that area. If you're looking at a cantilevered balcony or walkway or terrace or anything on that sort of line, then utilising the product as a cold bridging element between the balcony and the internal usable space will be ideal for that product as well, purely due to the fact that what you're doing is utilising a high performance insulant to negate any cold bridge through that access. So that at this moment will be at the best position for it, but please bear with us, and we're working on it to get it involved in not only roofing application, but also from a balcony and terrace application.
Okay, that's great. Thank you very much. Brian has asked, Callum, I'll come to you because you quite like the crypticish ones. If I can find it, I think it was, yeah, what's the smallest space flame can get through?
Any space, really. There's no minimum. Obviously, a larger space will allow more airflow and therefore more a faster fire spread. But it can pass through any space.
Okay, so it can. So basically, it will go where it wants to go if it's coming in contact with the correct materials, essentially.
Exactly. Yes.
Okay, good. And Elizabeth has asked, are membranes not exempt from approved document B?
Okay, so approved document B says that they don't have to be the A2 S1D0 that most other materials in construction do have to be. But it further clarifies that on relevant buildings, they do have to be class B S3D0 or D1.
Okay, that's great. And Callum, while I've got you, we've had one more in via email from Kevin. Will the use of Fire Shield and Protect A2 help to satisfy the LABSS Info Paper 22, which relates to timber frame construction, noted as Detail 3 in the Scottish accredited details, which have a service void and additional insulation?
I'm not sure on that one, but it's something I would have to look up. I'm not 100% familiar with the details off the top of my head.
That's
But
fine.
I will look that up and I'll get an answer back to you on that one.
Perfect. I will forward that one to you, and you can action it after today then. And Mark, I'm not sure we'll be able to answer this one actually, because I know we're looking into some of this at the moment, but Roland has asked, can you tell us more about your membrane, how it interfaces with EPDM, and how we see EPDM specifically being addressed by the new code requirements, given it cannot meet Class B or better?
Yeah, okay. Well, we're having sort of conversations with sort of allied manufacturers and that type of thing at the moment with regard to EPDM. As I said earlier, one of the advantages with the wrap type is in a lot of instances, particularly with concrete frames, it can actually remove the requirement for EPDM, particularly on concrete columns and floor zones, etc. So it can keep that to, reduce it just round to window openings, and that sort of thing. Yeah, I think that's something that we'd have to discuss or come back to in more detail, and perhaps have a conversation with him directly, and take that forward from there, really.
Great. Yeah, it's a good question. It's something that we are discussing internally at the moment. So Roland, if you could drop us your contact details, because that was on the YouTube feed, then we will pick that up with you afterwards as well. Jeremy, excuse me, has asked, is A2 non-combustible or of limited combustibility?
Okay. As per the webinar, that it was obviously gone over in some detail, but it's worthwhile highlighting this as well. There's still quite a lot of confusion out there from the point of view, we get questioned on it all the time, because people want non-combustible A2, and it's obviously stipulated that A2 is of limited combustibility, according to the test criteria of EN 13501, the fire test to building materials in England, Ireland and Wales. A2 is classified as limited contribution to fire, and in Scotland it's classified as no contribution to fire. This is a historic classification for Scotland, but in regards to the UK, it is classified as limited combustibility. The confusion lies obviously with governments stipulating that non-combustible insulants need to be utilised, and then obviously from an ADB point of view, then putting into those clauses that class A2 S1 D0 is the acceptable classification for certain products to be used in the facade system. So we believe that that's where the quandary lies. But as with ADB, again, as alluded to in the presentation, take what you will from it, make up your own ideas out of it, understand what you will from it. And they need to be more specific. Obviously, with Dame Judith Hackett's report as well, the guidance in there is to be more specific in regards to the building regulations, to make sure that everybody understands completely what's required of them. So there's a lot of information on the products out there, so please research the products properly and request certificates and indeed ancillary product specs as well at the same time.
Yeah, good point. Okay, great. Mark, if I come back to you, please. From Aaron, can Space Therm A2 be easily cut on site to form thermal bridging strips?
Yes, it can. It's fairly easy to cut down on site. It's a very easy product to work with. You can use a bandsaw, jigsaw, or craft knife. If you work in an enclosed area, I'd recommend sort of goggles and face mask and that type of thing. But actually, on some of these high-rise residential projects, you'll probably find that the requirement is the same, perhaps around window openings, cold bridging, etc. So we can do that for you. We can actually pre-cut the material down. So it comes in a standard 2400 by 1200 sheet, as it were, 10 millimeters thick, and then goes up in 10 mil increments up to 40 mil. And we can also bond that together. So if you need something at 60 mil, for example, as we showed in the webinar, then we can provide that as well. So we can provide it either pre-cut in relevant strips, or you can do that easily on site. So yeah.
Okay, that's brilliant. Thank you, Mark. Callum, I'll come to you first with an email one, and then I'll try and address one or two that are outstanding on the YouTube feed. So Derek has asked, what counts as a relevant building in approved document B?
Okay, so a relevant building is any building that has a floor over 18 metres and includes a dwelling or institution. So that means that any flats or hospitals are relevant buildings, but things like offices and hotels aren't. It also includes ones that are within 1 metre of our boundary. So the relevant building there is also in that condition.
Okay, that's great. Thank you, Callum. And Pranjal has asked, can an integrated approach with system designers need to analyze building components as a total package? So is that useful? So I think they're asking, is an integrated approach analyzing all components within that build up useful?
Yes, so that ties into a question we had earlier about whether it was possible to use a fire engineer to design without using approved document B. So yes, it is possible, but as it's not something that we can advise on. Our products can still be used as the same principles apply, but it would be done by a qualified fire engineer.
Okay, that's lovely. Thank you very much, Callum. James, if I can come back to you, I think that I've got all the YouTube ones, so some final ones coming through on email now. If there are any additional, please post them on the YouTube feed or email them through now. So James, Julie has said, Scotland have reduced the high-rise classification to 11 metres, and will England, Wales and Ireland follow suit?
Great question. The general consensus is that yes, this will happen. There are ongoing consultations headed up by the Housing Secretary, Rod Jenrick. The 11-metre limit would see any building of more than 4 stories being affected in the choice of combustible materials in both the structure and the cladding. It was suggested that 11 metres is an acceptable limit of traditional external firefighting techniques. Obviously, as before with the 18-metre rule, that was the ruling historically in regards to the length of a fireman's ladder as well. So they're following suit, obviously, with consultations with the fire services that the sort of efficient length of a fireman's ladder is 11 metres, and obviously the fireman servicing that area. Albeit the government admits there's no comprehensive research that supports the firefighting limit, and also that the evidence to support any specific height threshold is limited. The most recent changes, in all honesty, have happened very recently, which have been signed off to be in effect of the 26th of November in 2020, where sprinkler systems in residential blocks of flats have been reduced from 30 metres down to 11 metres in England. So they're starting to reduce down that level of height to 11 metres through the systems. Obviously, with COVID kicking in of late, it sort of put back the consultations and the deadlines, but there may well be in the not too distant future the reduction of those heights from 18 to 11.
Okay.
And hopefully including student accommodation blocks.
Okay, thank you, James. Great. Mark, Sadie has asked, in terms of design and site support, what support services can you offer? This is a question we get quite frequently, actually, each week. So yeah, design and site support, what services can we offer to help support people?
Well, I think since really this sort of pandemic has sort of presented itself, what we've done as a business is to continue that technical and commercial support to our customers via a skeleton team, as it were, and operating really from our home offices. So what we've done over that time is really sort of embrace this and take on board these different platforms such as Zoom, Microsoft Team meetings, etc. And that's allowed us to host these sort of weekly webinars and attend meetings, host or attend meetings. So with design teams, that can is great to share screens. So it's allowed us to look at drawings and then share installation guides, refer to data sheets, and that type of thing. So it's been useful to have some really interactive meetings via some of these platforms. When it comes to contractors, we can also do that as well. So whilst we'd ordinarily go to site and do hands-on sort of installation training, we've put a number of things in place, presentations via Zoom, meetings, etc., whereby we can go through the installation process of the membrane systems. Some of that will include video clips, etc. So there's a lot of things that we can still do, even though we're all sort of locked away at the moment. But if necessary, I guess, a bit further down the line, as things become more relaxed, we'll be able to return back to our usual format of doing sort of face-to-face live installation.
And hairdressers and everything else that we will need, or I need. Okay, great. So Callum, last couple of questions, a couple from email. Bob has, well, he's asked if we can circulate some details to some people. That's absolutely fine. And as the question is, sorry Callum, as BS 8414 is a field system test, do we have a list of systems that contain our products which have been approved?
Yes, we do have a list, and if you forward me that email, I will send it across to him.
Okay, that's great. So Bob, we will be back in touch. Another email in which I'm not sure I can answer in too much detail now, from Rob. Rob has asked, in terms of our membrane systems, are they subject to durability testing? Many specifiers are looking for guarantees on product performance in properties such as adhesion, fire, etc. So yeah, we got a lot of different testing on our different membrane products for different areas such as breathability, fire, etc. So we would have to look at them on an individual basis and at the application. So sometimes we work with the built-up systems manufacturers to talk about the overall performance of that build-up. And of course, our products have product performance characteristics over a number of years as well, which differs for the product and the application. So that's something that we could look at in more detail, Rob, but on a more individual basis for each product. So again, that's something that we can hopefully pick up with you after the webinar. And let's have a look here. We've got one last question, I think, and I'm sorry if I've missed any that have come through, but I do try my best. Jim has asked, so Callum, if I can just come to you for the last one, what is the difference between Class O and A1 and A2, or A1, A2?
Okay, so Class O is a mostly outdated class from the British Standard 476. It was a test method that relied on the vertical spread of flame testing, whereas the more modern Euroclasses, so A1 and A2, rely on a more complete testing of how it performs in practice. This is the reason that some ACM panels, for example, tested well under BS 476 and had a Class 0 surface spread of flame rating, pardon me, but in practice were a bit more of a fire risk.
Okay, that's great. Thank you, Callum. Well, thank you to all three of you guys, actually, for answering those. Well done. I know it's not easy when you can't see them, so in advance. So yeah, I really appreciate that. Thank you very much. Thank you to our attendees, and thanks again for posting some of the comments that are coming through in the YouTube feed. You know, informative webinar, well done, I'll be back, that kind of stuff. It's really encouraging to read, and I know it will be encouraging for our marketing team who got this finalised last night. I think around close to midnight it popped through. So they've been working really hard, a week to put something together with these type of visuals and this much educational information is not an easy task. So well done to you. I'm sure you're watching with the cocktail right now in the sunshine somewhere. Team marketing. So well done. We are back in 2 weeks today at 10 AM, same time. The topic is advanced membranes for offsite housing. Again, I said at the start of this webinar, something we know an awful lot about is the offsite sector. We've got traditional big customer base there and it's always increasing, and we've got excellent products and solutions for that sector. So that should be a really interesting one if you can join us. You will receive an email after this, which if you've registered on our website, of course. So please circulate it to anyone else if they want to rewatch the webinar. There's no limitations on who you can send it to, so please circulate it. And if you can fill out the survey, we would appreciate it. Again, any feedback is good, positive and negative. So we do take on board any constructive comments or suggestions, how we can do things better. So you can register for next week's webinar now. Go to our website, www.proctorgroup.com/webinar, and you can also, if you are looking to download a CPD certificate to show your attendance here, in the feed below the video at the moment, you will see a link, so you can actually go and do that right now. So that's it. I hope everyone has a lovely weekend. We're in for some sunshine, I think, which is absolutely fantastic. And hopefully we can see the other side of this lockdown at the moment, or slowly in Scotland. But we are kind of starting to emerge out of it, and it's nice to see. So thank you all for attending and have a lovely weekend.
Thank you very much.
Okay.
Thank you.